Now let's go ahead and work a centripetal force problem together. This problem is going to test your conceptual understanding of centripetal forces, centrifugal forces, and whatnot. Not only that, but this is going to be a great example of how the MCAT loves to test you in general. Keep in mind that the MCAT is a conceptual test. They do not like to reward strict memorization. They want to reward your critical thinking and your problem-solving skills. And they do that best by testing you on topics that you are already familiar with, things that you have already studied before, like centripetal force in this case, but by presenting them in a way that you've probably never thought about before. And that's what makes the MCAT so intimidating and so difficult for so many students. So let's go ahead and work through this problem, and I want you to really take the time to think carefully about each question I ask you so that you can make sure that you are developing the kind of skills you need for the MCAT and not just learning information. So what we've got here is this roller coaster, and let's say that this roller coaster is going to go through this loop, and we'll assume that this loop is a perfect circle and that it has a constant radius all the way around the circle. Not only that, but we're going to assume that our roller coaster is going to travel at a constant speed throughout this loop. And the reason why I mentioned speed is because the velocity will be changing, because the velocity is constantly changing direction, right? But the speed will not change, which means the value of velocity will not change. So we're going to use that so we can kind of ignore the signs and everything, and we'll just worry about the value of our velocity remaining constant here. And not only that, but we're going to assume that our mass is going to stay the same, right? Hopefully nobody's going to be falling out of the roller coaster, and so hopefully the mass will not change. So considering all that, how should the centripetal force compare at points A, B, and C as this roller coaster goes through the loop? You should have answered that the forces are equal at all points. And the reason why is because using our knowledge of what centripetal force is, which in this case is mv squared over r, we know that our mass remained constant, the value of our velocity remained constant even though it was changing direction at each of these points, and the radius of our circle remained constant. So that indicates that our centripetal force at each point indicated A, B, and C is going to be the exact same. Now go ahead and take another second to think about what real force is causing our centripetal force. And be very careful with this one. You should have answered that it actually depends. There are two forces in this case that can contribute to our centripetal force. Those two forces are our normal force and our gravitational force. And we're going to talk about how these two forces come to play in this situation to contribute to our centripetal force. So let's go ahead and start off by taking a look at point B. When the roller coaster is at point B, what direction should our gravitational force be pointing in? You should have drawn a downward line. Our gravitational force at this point is going straight down towards the center of the Earth, right? But what direction should our centripetal force be pointing in? Okay, you should answer that our centripetal force is pointing directly towards the center of the circle, because that is always the direction that centripetal force occurs in. So in this case, you can see that our gravitational force cannot possibly be contributing to our centripetal force because they are going perfectly perpendicular directions, which means there is no component of our gravitational force that could be contributing to our centripetal force. So in this case, that tells us that 100% of our centripetal force is being caused by our normal force in this case. So at point B, our normal force is exactly equal to our centripetal force. So now I hope you're starting to understand how these two forces, normal force and gravitational force, will work together to contribute to our centripetal force. So take a second to think about how our gravitational force and our normal force will work together at point A and at point C, and tell me at which point will our normal force be greatest. Now keep in mind I said normal force, not centripetal force. We already talked about how our centripetal force was constant at every point. Now I want you to tell me at which point our normal force is greatest. You should have answered that the normal force will be greatest at point C. Now, a lot of students think that this is a trick question. We talked earlier about how our centripetal force was equal at every one of these points, A, B, and C, right? But I didn't ask you about the centripetal force here, right? I asked you at what point was our normal force the greatest. And our normal force can change because our normal force is contributing differently to the centripetal force at point C as it is from point B and it is at point A. So let's go ahead and talk about how it's contributing differently. So we already talked about B. But now let's go ahead and take a look at A. Okay, so at point A, we can see that we're again going to have our constant centripetal force, again pointing towards the center of the circle. But in this case, we also have our gravitational force. Remember that our gravitational force is pointing straight down towards the Earth. In this case, you can see that it's going in the exact same direction as our centripetal force. So what that tells us is that our gravitational force will be composing a portion of our centripetal force. So if our normal force is going to be contributing to our centripetal force as well, it is what is going to be responsible for making up the rest of that vector. So in this case, it is our normal force plus our gravitational force that both work together to sum up to our total centripetal force. So now let's take a look at point C. At point C, we again have a gravitational force. And again, our gravitational force is pointing straight down. But keep in mind that our centripetal force still has to be a constant value, meaning it has to be equal at this point as it was at point B and as it was at point A. But in this case, you can see that our gravitational force is not really working together with our normal force. It's actually opposing our normal force. Our normal force will actually have to be much greater in value than our centripetal force in this case in order to make up for the opposing gravitational force. So in this case, our centripetal force is equal to our normal force minus our gravitational force. And so in this case, our gravitational force is actually working against our normal force and making it harder for our normal force to cause the same value of our centripetal force. So that explains why our normal force is greatest in the circle at the bottom of the circle, or in other words, at point C. So if you had a hard time understanding this topic, and I understand that this is a very confusing topic, but if you would like to go over it more with me in person later on, then just go ahead and give me a call or send me an email and we can set up a time to meet so that we can discuss any other difficulties you are having with this problem. I understand it's a very difficult topic and a lot of students really struggle with it, but so far we've covered what most students struggle to see. And if you have any additional specific needs, then please contact me.